This program is for binary search for numbers. So binary search means what? If there is an array, we are trying to divide this array into two parts. Okay, and then again we are searching the element depending on the condition. If your element found at the center, no need to check in left part or in the right part. But if your element is not found at the center, then you need to check in the left part or the right part depending on your number. But for this, what is our requirement? We need our array in a sorted order only. Okay, then only you can search if your element, if your key is greater than the center, you can find out this element in the right part only. But if your key is less than your center, then find out this element, this inside the left part only, in the first half part. If your element is greater than mid or greater than the center, then find in a right part means the second part. And if your element is less than center element, then find your key in a first part, that is your left part. Okay, so see here hash include stdio.h, then int step count, sub count, and the comparison count. Okay, here we are using the step count, comparison count, sub count. Then binary search, here is your array int I, int j, int k. Okay, here is int k. Then after this,
हॅलो मॅम.
yes,
मॅम इथं आपण वरती डिक्लेअर केलंय इंट स्टेप काउंट 0, स्वॅप काउंट 0. तिथं आपण नंबर इनिशियलाइज करू शकतो का?
no need to initialize the sub count, step count. Why it is 0? Initially all the are 0. If there is a steps, if there is a comparison or the sub condition occur, then only it will increase the comparison count. So initially it is 0 only. If there is a no comparison or no swapping, no need to increase, it will not change 0 to other number. Initially all are zeros. Okay, because this is your initial condition. And if there is a comparison or if there is a swapping, then only it will increase the 0 to other number. Okay, then only it will increment the this swap count or the comparison count. Okay.
Okay.
See, int a of 30, key, and I, and result. We require these elements, these variables. Printf, enter number of elements. How many elements in your array? I want suppose 4 elements. So then n value will be 4. Then enter a sorted list of 4 elements. Percent and here is n. Means what? I want the 4 elements. So give the proper message to the user. Enter a sorted list of 4 elements. Then for I equals to 0, I less than n, I plus plus. Here accept this 4 elements. So for the 0, it will accept first. Percent the address of a of I means element at the 0th location. Then for the first location, second location till the n. Okay, accept the data. Then here enter the element to be searched. Which element you want to search? I want suppose the particular element. Then the enter the element to be searched. Then scanf percent the address of key. So I want this element. So read this value from the user. I want to search this particular element, that is your key. Then result binary search a, 0, n minus 1. What does it say? For the binary search, we want the argument first. Int a means your array. Int I and j are the two indexes. And int key means your key element. So pass this algorithm. Do the call. This is a function calling. So when this statement occur, it will automatically jumps to this line. Okay. So here int c. C means what? We need to find out the center. For what? Because this is binary search. So we need to divide the whole array into two parts. So on depending on a center. Okay. So first find out the center. C. If I greater than j, then comparison count, increase this comparison count. Then step count equals to step count plus 2. Increase we are increasing this step count also, this first and this is second one. Then return -1. Why return -1? If no, if I is greater than the j, then return -1. Otherwise, if your array is exist, then what to do? Find out the center. Okay, find out the center. C equals to I. See, in this condition, I greater than j means, suppose your array is only, suppose array is, in array your exists a 0 element. 0 is greater than 0. Or in some condition, when we are dividing the array, then at that time we need to check this condition also. I is our lower bound and j is our upper bound. But this showing as your lower bound is greater than the upper bound, then you need to return -1. If not, means if your array is exists, say equals to I plus j by 2. Means suppose there are 4 elements or the 5 element, then starting index is 0, I value is 0 and j value is, suppose the 5 element, then the j value is 4 because array is starting from the 0. So 0 to 4. Okay, so 0 plus 4 divided by 2. So C is 2. So A of C means from the second location we will first compare at the center our keys exist or not. If our key exists at the center only, no need to check in the left and right part. So key equals to A of C. If your key is found at the center, then write your comparison count, step count, increase this and return C. Return the location, that is center location, your element found at your center location only. This is your base case of your algorithm. If your key is greater than A of C, means what? If your element is greater than your center element, then you need to again search, you need to this process again. So here we are calling these functions once again. So this is known as a recursion. Okay, so we are giving this call to this function only. Recursion means what? The function gives calls to itself till the some satisfied condition. Okay, condition gets satisfied. So binary search, here is the array A. Here is lower bound is what? Now lower bound is C plus 1. See, here initially lower bound is I, but here is the lower bound is now C plus 1. Means the in the right part we are trying to search the key, then J and then K. If this key is greater than this, we will do this. But if our key is less than A of C, means your key is less than center, then you need to go with this line. Means binary search A, I, C minus 1, key. Means in a left part. Okay. So let's see. We will execute this program on online compiler. So Control A to copy, Control C, Control A, select all and then copy all this code. Go to the online compiler. See, here we will paste our code. See, here is the code, binary search for the numbers. Okay, so just how to use this online compiler? Just go to Google and type online C compiler, or you can write this onlinegdb.com. See, here is your program. Okay, so just click on a run to run this. Just click on run to run this code, and after compilation your output will be here. See, here is a compiling program. When we are using the Linux system, at that time we are compiling the program by using the command. See, here is some problems. Just wait. This is the online compiler, so you need to wait for the internet connection. Okay. Again click on a run to run this code. See, here enter number of elements. So how many elements you want in your binary search in array? Suppose I am entering just a 4. Okay, so enter the sorted list of 4 elements. But here is first condition is your list must be sorted. Here is a sentence sorted. So enter the element. Suppose my first element is the 4, second element is 88, third element is my 89, and last element is my 100. Okay, which element you want to search inside this array? Please tell me which element. See here, enter the element to be searched. Which element you want to search inside this array? Suppose I want to search the element 89. So just press enter. So this element found at location 3, number of steps, number of swaps, number of comparison. See here is number of steps, swaps and comparison. So element found at the location 3rd. Okay. Again, if you want to search for the other element, you can just press run. Okay, just click run or press F9. So you can check for the other elements also. This is a program for binary search for the numbers. You can write the same program for binary search for students or binary search for the strings. Okay.